Hello class, this is Mr. Lehman. Today we want to talk about ions and get into a little bit of ionic bonding and ionic formula writing. So, if we look at the main group elements, representative elements, we talked about in previous units, Unit 4, the electron dot diagrams. So if we get right across period 2 of the periodic table, so starting with lithium and going across, lithium's row, lithium's period, we learned how many valence electrons each of these elements have in each of the main group elements. So let me just go ahead and write down the symbol for each of the elements that are going to represent their families. So the alkali metals all have one valence electron, and the alkaline earth metals have two valence electrons. And group 13, the boron family, they'll have three valence electrons. And carbon, everything in carbon's family has four valence electrons. And so what I'm doing here, I put one dot on each side. I pretend that the element symbol is inside of a four-sided box. And so I'm going to put one dot on each side of the box before I pair up. But nitrogen has five valence electrons, so pick one side to put a pair, and the other three sides will get a single electron. Once again, these single electrons, these dots represent valence electrons. So it's a simplified way of drawing Bohr models, because really when it comes down to a Bohr model, we only really care about the electrons on the outside, the valence electrons, because those are the ones involved in bonds. And so for fluorine, fluorine has 7 valence electrons like all the other halogens do. And neon, our representative of the noble gases, has 8. Alright, so in nature, whatever takes the least amount of energy is what's going to happen. And so lithium has 1 electron, so you could steal 7 or it could lose 1 to get a full outer shell. And if you remember that octet rule, most atoms want to get 8 electrons, a full outer S and a full outer P, to equal stability like a noble gas. Noble gases have a full outer S and a full outer P. And so lithium can either lose 1 or gain 7, so it's a lot easier for lithium to lose 1 electron. And if lithium loses 1 electron, its oxidation number, its charge, will be a positive 1. And beryllium has 2 valence electrons, and so it could steal 6 or lose 2. It takes less energy to lose 2, and so beryllium will lose its 2 outer electrons and become a +2. And boron, aluminum, things in this family, will lose 3 rather than gain 5, because that takes less energy. So boron, aluminum will get a positive 3 charge when they're stable, when they have a noble gas configuration. And carbon, in theory, it likes to share, but it could lose, it could gain 4. Neither happen that often. So carbon, depending on what happens, if it lost 4, it would become a +4. If it gained 4, it would be a -4 charge. Nitrogen has 5. It's easier for it to steal 3. And if you steal extra and add extra negative charges, that makes the ion negative. So nitrogen gets a -3 charge. Oxygen loves to steal as well. It loves to steal 2 electrons and become -2 charged. And fluorine, like all other hydrogens, very easily steal 1 electron from other atoms and get a -1 charge. And neon will keep a 0 charge, a neutral charge, because it already has a full outer shell, so it's not going to gain or lose any electrons under normal conditions. So if we know the charges of these groups, then we can figure out what's going to happen whenever they link up. Alright, so once again, this family gets a 1+ charge, this family gets a 2+ charge, this family gets a 3+ charge. This family could get a 4+ or a 4-. Nitrogen gets a -3, oxygen gets a -2, fluorine gets a -1, and our noble gases remain neutral. So the question is, what happens if lithium links up with, let's say, oxygen? So let's do lithium and oxygen. Well, lithium wants to lose 1 electron, become +1. Oxygen wants to steal 2, and so we get, and another word for a positive ion is cation, and another word for a negative ion is an anion. So this lithium cation wants to form up with the oxygen anion. And we actually don't call it oxygen. For anions, we replace the ending, the YGEN, with the suffix IDE, so we call it oxide. Alright, so lithium is going to link up with the oxide ion, and the charges have to be equal and opposite. So right now, this +1 doesn't cancel out this -2, and so we need more of the positive charges. And so we're actually going to get 2 lithium ions each one being a +1 to link up with this -2 oxide ion. So the charges have to add up to 0 because all compounds are neutral. All compounds have no charge. And so if we need 2 lithiums, the way we write this formula then is Li2, 2 lithium ions, 1 oxygen, 1 oxide ion, but we don't write the 1. So this is the formula of the ionic compound that forms between the lithium ion and the oxide ion, and we would call this lithium oxide. If we look at another one, if we look at, let's say, aluminum, which likes to become +3 because it's in group 13, it loses 3 valence electrons. And we look at oxygen, which we call oxide ion. Now, what's the lowest common multiple in 3 and 2? The lowest common multiple of 3 and 2 is 6. So how many +3 aluminums do we need to get to a +6? We would need a total of 2 aluminum ions to get a +6 charge. How many -2 oxide ions do we need to get to a -6 charge? We would need 3. 3 times 2 is 6. And these two will cancel out. These two will add up to 0. And so once you figure out how many of each ion it takes to neutralize each other, then we count them up. We needed 2 aluminums. We don't write the charge in the formula. We just use these charges, these oxidation numbers, to figure out how many of each we need, and then we don't worry about writing it in the formula. So Al2 meaning we need 2 aluminums. O3 meaning we need 3 oxides, 3 oxygen ions. And this is the formula. If you ever get to a point where they're both divisible by the same number, then you need to simplify, reduce. Alright, so we wouldn't write Al4O6. We would need to reduce that to Al2O3. Alright, some things can have more than one charge, and let me just save that for the next tutorial. So this is the basics of formula writing binary compounds. So if you need help with the transition metals, the polyvalent ions, check out the next tutorial. Thank you.